Thank you everyone for joining this evening. I'm going to give people a couple more minutes to finish logging in, so I will get started around 2 or 3 after 7. Thanks. All right, well, thank you all for joining me this evening. I'm really excited to chat with you guys about some of the work that I do here at MGH. My name is Charles Bormann. I'm the IVF Laboratory Director, and I'm really in charge of making sure that the laboratory runs smoothly, to making sure that we optimize the conditions in which embryos are cultured and really do our best to make sure that the embryos have the best possible environment to grow. Throughout my talk today, please feel free to type in questions, and if you can, do it in the Q&A bubbles if you see that on your page. I'll try to answer them as I go, and if not, I'll answer them at the end of my talk today. So my talks are generally very heavy on images because I think it's easier to learn that way. And today, I'm really going to be talking about overall embryo culture or embryo grading and how we grade embryos or assess them for quality, and some of our policies at MGH on how we decide when we'll perform an embryo transfer and how many embryos patients are eligible for transfers. So here's just a reminder. Here is kind of an image of a uterus and embryos development. So for starters, what we do is we collect oocytes, and that can be from a stimulated cycle where we're actually doing a minor surgical procedure after we've stimulated some ovaries to collect as many ovum or oocytes or eggs for an IVF case. And so that's if we're doing something with a fresh cycle. However, sometimes people use frozen eggs, whether it's because they froze in the past for fertility preservation, or maybe they're using donated oocytes that were frozen at another center. And in any case, this is where everything begins. So we start with the oocytes and we do the insemination. Insemination is where we combine the eggs with sperm. So I'll go over that in a little bit more detail on the different ways we might inseminate eggs to get fertilization. And then the rest is really development. It's when the embryo is at the 2-PN stage or 2 pronuclei stage. And then when it progresses on to a 2-cell, 4-cell, multi-cell embryo, and all the way to the blastocyst stage. And that's the stage in which an embryo will actually implant inside of the uterus. So I'm going to take you on a journey through these developmental stages and how we assess them throughout. So here's some imagery, a cartoon of an oocyte retrieval, where there's actually a vaginal probe where there's a small little fine needle that actually goes into the ovary and harvests the eggs. So you can see in this bottom left-hand corner, these dark black little pouches here, these are follicles. These are on the ovary, and within each of these dark-filled follicles is one oocyte. in each one. And so what they're doing is they use a needle and they aspirate these follicles to collect the eggs. And what we do in the laboratory, this is where I come into play, is we search for these eggs. So we have 2 people assigned to each case where they're actually looking under a microscope into all of these dishes and they're searching for every single oocyte. And they do double and triple checks to make sure they get every egg in that dish. And so this is a blown up image here. Up on the upper right is what the oocytes actually look like after we've retrieved it. So you can see it looks kind of like a sun. In the middle, you see that circle, and that's actually the egg right here. And then all around it are cumulus cells, and they completely surround this egg. So if we were to remove all of those cells that you just saw, all of those cumulus cells, this is what the egg would look like inside one of these images right here. So when the eggs come out and we clean them off for other procedures and remove the cumulus cells, they can be at different stages of maturation. So in the upper right-hand corner right here, this oocyte's at the germinal vesicle stage. And you can see that based on this really big, it almost looks like a vacuole within the oocyte. And this egg is not mature. And this egg is not even capable of being fertilized. This next egg right below it is at the metaphase 2 stage of meiosis. So here, it's also not mature. It's not capable of being fertilized. And what we see when we do retrievals, which is pretty normal, is about 80% of all the eggs that are retrieved on average are mature and capable of being fertilized. And what is a mature egg? A mature egg is like this one right in the center. It's a beautiful cell, and right here at the top, you can see a polar body that's been extruded. So you don't see that in these 2 images right here, but you do in this bottom one. You can see the small cellular body that has been extruded from the oocyte, and that shows us that this egg is mature and capable of being fertilized. So there are a couple ways in which we can fertilize these oocytes or these eggs, and these are the 2 approaches that practices use. One is conventional insemination or traditional in vitro fertilization. And this is when we take the eggs and then we take the sperm and we mix them together in the dish. So we'll put hundreds of thousands of sperm, highly motile sperm, inside a dish with the eggs. And the first one to break through, swim through all of those cumulus cells and penetrate the egg is the winner. That's the one that fertilizes the egg. However, there's sometimes, and what we see in fertility is that almost 50% of the time, there's a male factor involved. So it's not just a female issue. That's not the main reason that people have infertility issues. About half the time, it's also a male issue. And in these cases, when there's any kind of sperm motility issue or low sperm numbers, or maybe there's abnormal sperm morphology, or maybe they're doing other procedures as well, like they're going to do genetic testing. In these cases, patients opt to do ICSI. And even in our practice alone, over 80% of the time, people are doing ICSI on these cases. So I just had a really great question. Are all my eggs and all the sperm put in one dish for insemination? The answer is no. So we don't put everything into one single dish. We divide them into different dishes. So we never inseminate more than 4 eggs in one dish. And in that way, we don't want to put too high of a concentration of sperm. We try to balance it out. So we are very specific in the numbers of sperm that we are inseminating eggs in. Our concentration for conventional insemination is 50,000 motile sperm per dish. And so we're very conservative. That sounds like a huge number, I'm sure, but that's actually a very conservative number of how many eggs and sperm that we put together. So, great question. And how do I choose the sperm that we're using for ICSI? Another great question. So there's different things that we're looking at the sperm when we're trying to select which one we feel is the best to capture and put inside the oocyte. So what we're looking for are the ones that are forward progressing. We want them swimming in a straight line if possible, because we know if we are thinking about how everything would work with Mother Nature, that's the sperm that would win that race, right? It's not going to be the sperm that's just twitching side to side. It's not going to be that sperm that's swimming in circles. It's going to be that sperm that's swimming in that straightforward progressive manner. We're also looking at other structures on the sperm. We're looking at the head. We want the head to be a normal shape. We want the neck piece of the sperm to be normal in its proportions to the head, and also the sperm tail. We're looking at features on the tail to see which one is the most morphologically normal when we're selecting it for ICSI. So here's an actual ICSI procedure. So when people say ICSI, they're saying intracytoplasmic sperm injection, big fancy word for sticking that sperm directly into the egg. So here's a quick video, and I hope it works for you guys. Okay, let me click on it. Okay, there you go. So you can see here at the bottom is the extruded polar bodies that I was talking about, which means that the egg is even capable of being fertilized. And there you can see that needle up at the top. And at the tip of that needle, if you look closely, there's an egg. See, it's going back and forth, and it was deposited right here inside of the egg. So it's completely deposited, and now that sperm is going to do its magic in the egg over the course of the evening and hopefully fertilize. I'm going to play it again just because it went pretty fast. So again, we've already selected what we thought was the best quality sperm, right? After we've captured that, we are putting it directly inside that oocyte, and we're doing it far away from the extruded polar bodies because there's a metaphase 2 plate in this area, and we don't want to damage it. So we're very specific on where we line that egg up before we inject it with sperm. So after we've injected the egg with sperm, we give it between 14 and 18 hours to do its magic. And that is for it to really kind of decondense and to start forming within the egg itself. And so between 14 and 18 hours after fertilization, we assess each egg individually to see if it fertilized normally or not. And so when we say fertilize normally, we're looking for oocytes that have 2 pronuclei within them. So it assumed that is one of the pronuclei contains the female DNA from the mother and one contains DNA from the father. So that's considered normal fertilization. If we arrive the next morning and we don't see any structures at all, then we know that the sperm didn't decondense and that it didn't fertilize, and that egg will not go on and develop. Also, if we look at it the next morning and we only see 1 pronuclei, it was abnormal in its fertilization and it will not continue development. There's also some other abnormal fertilization events that can occur. And here's some more extreme examples where maybe 1 sperm was injected and 3 pronuclei formed. So this can indicate that there was something abnormal with the egg. Here's a case where they did conventional insemination. And the reason I know that is you can see on the outside, you can see these tiny little sperm that were all bound to the outside of the egg. And what happened is multiple sperm must have penetrated this egg and fertilized the egg at the exact same time. And in this case, anytime there's more than 2 pronuclei, it's abnormal. And we don't keep these in development any longer because these will end in, these sometimes can implant and they'll end in a miscarriage. So things that can cause abnormal fertilization. So if we inject 1 sperm in, we know we only put 1 sperm in there and they have abnormal fertilization, which is more rare. That means there was probably some issue with the egg itself. There was probably some issue with the spindle of the egg. Also, if there's multiple sperm that got through, it also means that this egg wasn't properly blocking the egg sperm from coming in, because what normally happens is 1 sperm goes in and then there's a big shield that goes all the way around the egg and it prevents any more from getting in. However, something didn't work right in the egg at that time and more got through. So sometimes this can actually be corrected on future cycles that people go through by using ICSI. So we know we can control and only put one egg, one sperm in at a time. So what we do is we identify all the normal fertilized oocytes, 2PN embryos. Those are the ones that we keep in culture. So when I talk about culture, what we're trying to do is, this is our culture incubators, and these are culture dishes. What we're doing is we're trying to create an environment in vitro or within the laboratory outside of the body that tries to mimic what's going on inside the uterus as best we can, because we know that that's the best place for the embryo to be. So we are doing our very best to try to mimic these conditions. So these more plastic sterile conditions that you see right here are more like what would be going on inside the uterus. So a couple things to note, that throughout this entire process, everything that we do, every time we have a semen specimen, or we have eggs that are collected, or putting them together for fertilization, or we're developing these embryos, we do one patient at a time. And for every single step along the way, we have at least 2 people that double verify every step and make sure that, you know, we are tracking these cells perfectly. So when you look at an incubator like this, it's one patient at a time. We never share. So this is what we're trying to do in the lab. We're trying to make and mimic what's going on in vivo within the body. So to do that, we have extremely rigorous high-tech equipment to culture these embryos and test these conditions every single day. So for the first hour or 2 every single morning, we test the oxygen concentration, we test the carbon dioxide concentration, we test the pH of the media, we test the temperature of these systems to make sure everything is perfect for culturing these embryos. So, and this is what we're going to do. So I showed you kind of that diagram of that uterus and all the embryo development. Now I'm going to show you a time-lapse video of an embryo actually developing. So you can see here, these are in culture, and so it has 2 pronuclei. You can see them right here, and they're coming together, right? Because eventually the male and female DNA come together, as you just saw. I'm going to stop it. They just came together and they underwent singamy. And as soon as they undergone singamy, it's now 1-cell embryo, and it has the DNA that it's going to have when it's a fully formed person, if it continues to develop. You can also see here, and this is pretty cool to see, this was a conventional insemination case, because you can see all these little sperm on the outside of his eggs. These are all the ones that really tried, but they didn't win. 1 sperm got in. So what you can see is the embryo is going through changes now. It is starting to divide, and it goes from 2-cell, and then it'll go to 3-cell. So it's not like people usually imagine it goes 2 to 4. It doesn't do that. It goes 2 to 3 to 4 to 5. So it's one at a time, and everything is staggered, and that's what's really normal. You can still see right here on the outside, some of that sperm still kicking, but it's not getting through. So these embryos are cleaving. So right now, it's about 57 hours after fertilization. So right here, it's around day 3 of embryo development. And when it's on day 3 of embryo development, we like to see embryos somewhere between the 6 and 10 cell stage of development. And I'll go into that in a little bit more detail. But I want to show you what's really going on inside the laboratory during embryo culture. So again, these are 8, now it's at the 8-cell stage, and it started, you can see all the cells are starting to kind of move and get worked up. It's going to undergo a process called compaction. You can see right here. A few seconds ago, you saw all these individual cells, but now all these cells are coming together. All of their outside membranes are coming together, and it's becoming one. And this is the morula stage. And as it progresses, it's going to advance on even further. So here's the morula developing even further. And soon you're going to start seeing pockets. See here, I stopped it right here. You're starting to see these pockets formed. These are blastocele pockets. This is fluid is starting to come inside of this embryo, and the embryo is now a blastocyst. We are now on day 5 of embryo development, and a blastocyst stage embryo is forming. And as you can see here, throughout this entire thing, the embryo itself is getting larger and larger. this outside shell, which is called the zona pellucida, is getting thinner and thinner. I'm going to stop it now soon because the movie will be over. But what you can start to see is as this embryo progresses in development, it's starting to develop two separate cell lineages. So all of these outside cells kind of surrounding where this outside shell is, that gives rise to the trophectoderm. The trophectoderm cells are the cells that really end up implanting into the uterus and become the placenta themselves. This mass of cells right here, or the inner cell mass, these are the cells that actually give rise to the baby itself. So by culturing these embryos out to day 5 or beyond, we're able to start seeing the differences between these different cell types and being able to classify them. There you go. So it goes further and further, and eventually these can hatch. And that's a process that's needed before implantation. So I'll let it just finish out. Okay. So let's talk about day 3 embryo grading, or embryo grading at the cleavage stage. So what are we looking for in the laboratory? Like I said, on day 3, we like to see between 6 and 10 cells. That's considered pretty normal. Sometimes there's more cells at that stage, but that's typically when a patient asks, what's the gold standard? I think a lot of people are told 8 cells, and 8 cells is a great embryo. But really it's somewhere between 6 and 10 cells, which is pretty normal to see at that stage. So here's kind of a progression. You can see like a 2-cell embryo, which is really typical to see on day 2 of development. Then it goes on to 3 cells to 4 cells. It's at the 4-cell stage usually by the end of day 2 of development. And then by day 5, it starts to become, it becomes a 5-cell embryo, 6-cell embryo, 8-cell embryo, 9, and then even a multi. And this embryo right here has 12 cells. And so it does keep on dividing. And these are some of the things that we record in the laboratory as we assess embryos on day 3. So not only do we assess and count all the individual blastomeres in each embryo, we're also looking at the symmetry. We want to make sure that, like you can see on this 2-cell embryo, they're pretty much identical. So it's a perfect symmetry. So for a 2-cell embryo, this is pretty excellent. Even in this day 3 embryo, pretty excellent. What we don't like to see is, let's say if this blastomere right here was really tiny and the other ones are really large, that's abnormal. And so that is something that we record in the laboratory when we're assessing embryos. Same with fragmentation. So in most of these, you don't see any degree of fragmentation or these little blebs or kind of breakdown of some of these cells. It's all pretty smooth on the outside of these cells. However, if you look down here in the bottom left, you can start seeing a little bit of this blebbing come out, and that's a really slight degree of fragmentation, nothing severe at all. And actually, all of these embryos are quite nice in terms of symmetry and fragmentation. But I want to show you some that aren't so nice. So the first embryo you see here, you can count that there's 4 cells, 1 here, 1 here, 1 here, and 1 in the back. And you can start seeing more and more fragmentation right here. So, you know, between 10 and 20% of this embryo is actually fragmented, and we grade that accordingly. Here, it's well over 50% is starting to fragment. You can't really discern the cells as easily. Same here, you can start seeing fragmentation. And these are different things that we are always recording when we're assessing embryos on day 3. So, you know, there's different schools of why are we grading embryos this way? So on day 3, we're trying to find which embryo is the best quality for transfer. Because as we know in IVF, sometimes it's been given a bad rap because there's so many multiples that are out there. So we want to really reduce the risks and chances of twins or even higher order multiples like triplets, because it's really not the safest for the mom and definitely not the safest for the babies. We really want to limit the number of embryos that are transferred so that these can be safe pregnancies. So we really want to find the best way to grade these embryos and select them for transfer. So it's hard. Sometimes on day 3, if there's too many embryos available and they all look really similar, it's really hard to identify which one is really the best quality embryo for transfer. So there's other strategies. So if you have enough embryos, it's a really great strategy to actually continue culturing these embryos out to day 5 of development, because there's more ways that you can actually grade the embryos at a later stage. So here's the morula stage. And I talked to you about that a little bit, how all the cells kind of come together. And you really can't, it's a beautiful embryo for me, but it's really hard to grade and say which one is the best. And that's why a lot of people don't do day 4 embryo transfers, because it's really hard to discern between a really high quality morula and a low quality morula, because frankly, they all look really similar. On day 3, you have these different characteristics that you can distinguish, cell number, fragmentation, and symmetry. But at the morula stage, all of that kind of disappears. So that's why you don't see a lot of day 4 embryo transfers. The next stage is the early blastocyst stage. So we use, and one thing I really love about IVF patients is they study the internet. They do a really great job of educating themselves on embryo grading systems, and we get a lot of questions about this. So we follow what is known as a Gardner grading system, and there's no real universal grading system in IVF, but if there was, this is probably the closest one. So this is a researcher and a great colleague that I know out of Australia who developed this, David Gardner. And this is a system we use here at MGH. So at the early blastocyst stage, that's considered a stage 1. And that's right when we can start seeing this blastocyst cavity just beginning to form. So we know it's a blastocyst, but it's an early blastocyst. Sometimes we see that late on day 4 or really early on day 5. A stage 2 blastocyst is a little bit more advanced. And you can see that cavity that was forming before is becoming stronger and stronger. It's becoming much larger, and the embryo itself is starting to expand. And like I said before, you can start to distinguish the different cell types a little bit here on stage 2. You can start seeing this mass of cells right in the middle, and that's the inner cell mass. And the outside cells, those are the trophectoderm that give rise to the placenta. So not only can we grade the stage of the blastocyst on day 5, we can start breaking down characteristics like the inner cell mass, and we can give them a grade, just like you get on a report card, A being the best, D being the worst, right? And so, and we grade each of these. We look at the stage and the size, and we give a grade, and then we look at the inner cell mass and give a grade, and then we look at the outside trophectoderm, and we give a grade. That's how we grade our embryos. So that was 2. So on stage 3, again, the embryo is getting bigger and bigger. The blastocyst cavity is getting larger and larger. It's very clear and evident to see the inner cell mass that gives rise to the baby and the trophectoderm that give rise to the placenta. Here, these are really strong and beautiful images. But here, in this image right here, this is the inner cell mass, and you can see it's all kind of, the cells are pretty separated. So this would not be a grade A inner cell mass. Doesn't mean that it won't give rise to a healthy pregnancy. However, if we're trying to distinguish, do I want to transfer this embryo or this embryo, I would transfer this first one because it's a really strong inner cell mass. This one, it's a little bit loose, and you would like to see it a little bit tighter at this stage. Same with the one in the very bottom. You might want to see more cells in the trophectoderm instead of some large big ones. You would maybe want to see a lot more cells, and you would maybe want to see that a little bit more compacted in the inner cell mass. So these are the things that we're constantly grading in the laboratory when we're trying to rank which one is the top quality, which one is going to give our patients the very best chance of conception. So we progress, and just the grading system goes from 1 to 6. So here's another example. This is stage 4. You can see the zona pellucida, and that's that shell that I was talking about earlier, is getting extremely thin at this point because it really wants to start hatching soon. You can see here the trophectoderm cells, these are on the outside. However, there's missing cells right here. So this is not a great embryo. Even though the inner cell mass is quite beautiful, the trophectoderm is really weak. And if you don't have a trophectoderm, the embryo can't implant. So, you know, this embryo may not do that well in vivo. Here's an embryo that looks a little funky right here, right? Because it's kind of squishing down. But this is actually a really beautiful embryo. This is something that embryos do naturally. They expand and they contract, and they expand and contract. And that's part of the process of them trying to thin out the zona pellucida here and really escape and hatch from the zona. So this is actually a quite beautiful embryo. If we go through here, I think if you're learning to grade with me, you can see that this is really dissociated, this inner cell mass, and that it's kind of broken apart. Not the best, but these are the things and decisions that we are making in the laboratory every day. Day 5 is hatching. So I talked about the contraction and expansion. That's what these embryos are doing. So this outside shell is super thin, and it's starting to spill out part of the embryo itself because it's getting ready and it wants to implant. So this is a hatching blastocyst, stage 5. And in stage 6, sometimes we see this later in development, and sometimes we'll see this if we've had to do any artificial hatching for genetic testing purposes. But this is when the embryo actually fully escapes from the zona pellucida, and this is quite beautiful to see. This embryo right here actually has a zona on the outside, but it's starting to spill out. The embryo right to its left is completely outside of its zona pellucida. And I really love this picture in the middle, and found this on the internet. But this is a fully hatched blastocyst, and it's completely hatched out of the zona. So here, this is the zona pellucida. That's where it was developing this entire time. And then it hatched out and it really expanded development. So great question. I was just asked, which stage do you freeze them if it is the case to freeze? I think it's 2 slides away, so I'll get to that real fast. But these are fully hatched blastocysts. Oh, 1 slide away. Good question. So I just went over the BLAST grading system 1 through 6. But where we actually make our decisions for freezing them is on day 5 or day 6, they need to be at stage 3. They need to be at stage 3, and they have to have an inner cell mass and a trophectoderm that's better than a CC. So if it was a CIC inner cell mass and a C trophectoderm, we wouldn't freeze it. But if it was a C trophectoderm and a B inner cell mass, we would freeze that. Or if we're doing genetic testing, we'd biopsy that. So that is our criteria for what we are willing to biopsy and freeze, is a grade 3 or better. We don't do that on stage 1 or stage 2 just because they don't do well in the freezing and thawing. And if they haven't made, if all the embryos or any of the embryos haven't met freezing criteria on day 5, we give them all an extra chance. We let them culture 1 additional day to day 6 to see if they perk up and they progress on to development. But if they haven't progressed on to development by day 6, now they're a day or 2 behind in development, and it's not a good sign for these embryos. So we don't want to put patients, give them any false hope that these embryos would do well if we would freeze them. So we do have very strict criteria in which we would freeze or biopsy embryos. So this is a stage 3 and beyond. So how do we determine when we're actually going to do these embryo transfers? This is a really great question, and a lot goes into this, and sometimes it can be a bit of a moving target, right? And you look at your own internal data to determine what is the best for the embryos, what's best for the patients. And so based on our experience at MGH, we determine the day of transfer solely based on the number of normally fertilized eggs. So the number of tupiens, and here's the images below. So the number of normally fertilized, the ones with 2 pronuclei, we count the number available per patient, and that's how we decide when they're going to have their transfers. So, and this is for all age groups, if patients have less than 4 normally fertilized eggs, it's going to be an automatic day 3 transfer. If a patient has 4 or more, we culture them out to day 5 and we do a day 5 transfer. So, you know, we try to, that's our policy. And there are patients that have had success in the past with a day 3 transfer, and no matter what, they want a day 3 transfer. And that's fine. It's really up to you and your physician in when that will ultimately take place. We've had patients that say, hey, I only have one or two embryos, or normally fertilized embryos. I still want a day 5 embryo transfer. That's their prerogative. But the reason we do day 3 versus day 5, we cultured day 5 only for selection purposes. We think that is the main benefit of culturing out to day 5, is that we're able to assess the embryo on we have more criteria in which to select the embryos from. We, instead of just the number of cells, the number of fragmentation of symmetry, just those 3 parameters, we now can grade blastocysts, a 1 through 6 stage blastocyst. And for each one of those, we can give an A through D intercell mass and an A through D trophectoderm. So all of a sudden, we have so many combinations. It gives us more ability to rank order the embryos and really select the best quality embryo for transfer. But if you only have 1 or 2 embryos to choose from, it's better to be transferred back sooner. So that's kind of the rationale behind why we choose day 3 versus day 5. So really, this is kind of the final slide about our embryo transfer guidelines. For day 3 embryo transfer, this is what, based on the patient's age or the egg age. So if they're group 1 and that's their first or second embryo transfer with a high quality embryos available, these are the number of embryos they qualify for. And this is really based on a couple things. We look at SART, the Society for Assisted Reproductive Technologies. They've come out with their own guidelines for practices to follow to really optimize patients' chances of getting pregnant, but not just pregnant, but with a healthy pregnancy, with a single embryo transfer, or their best chance of having one single baby at a time. As you can see, though, as patients advance in age, they qualify for more embryos. And that's just because there can be high rates of like aneuploidy or chromosomal abnormalities in which embryos themselves just don't implant. And so more embryos are transferred to still try to get a high pregnancy rate without increasing multiples. Group 2 is for patients that maybe they've had a couple failed pregnancies, or they've had or maybe they don't have high quality embryos in their cohort, and that they would be served best by transferring more embryos at a time. And so this is on a case-by-case basis, but we've established guidelines here as well. One thing that you can notice, this top table here is based on day 3 embryo transfers if they qualify for day 3, and we tend to transfer more embryos on day 3. But if it's day 5, we have we're better able to select the higher quality embryo, and so we transfer fewer embryos on day 5, just because the rate of risk of twins is much higher. So I have a question here. It says, are these guidelines the same for embryos which were tested? Fantastic question. No, if we test embryos, and I think this person is asking if we do genetic screening. So if we've already determined that this embryo is chromosomally normal or euploid, in that case, we transfer 1 at a time. And we're very strict about that. The only time we would transfer a second euploid embryo is in a very rare case if a patient has gone through 2 transfers with a euploid embryo and did not have success. Then we would consider transferring a second euploid embryo, 2 euploid embryos at a time, to help them conceive. But based on our really high success rates, it is certainly safest for them to transfer 1 at a time, just because the risk of twins is so high. So a question that I'm using donor eggs and I'm at 44. I will be able to have 4 embryos transferred? No, great question again. So if you look at the table, that's why we specifically use language oocyte age, the age of the egg, because that's what's going to determine kind of the health sometimes of the egg, of the embryo itself. So usually if you're using donor eggs, they are generally under the age of 30. And so in that case, it's automatically going to be in that group 1 class. So no, you would most likely, if it's a cleavage stage, you're likely only going to get 1 back. And if it's a blastocyst stage, same thing, 1 back. Another question, is group 2 only with failed IVF, or does it include recurrent pregnancy loss? So this is very specific to our program where we've cultured these embryos and we've transferred it back. So I think she's asking that sometimes patients have, and it's really unfortunate, they've had multiple pregnancy losses on their own or maybe through another center, and so they maybe want to qualify for more embryos. But here what we do is in our own facility, I think we have a lot of confidence in our culture environment that we really want to not increase the risks of any other complications. So we're still holding fast at this and the number of embryos that we're transferring. So how often does it occur that there are embryos to cryopreserve after a transfer? Super. So in our program right now, when I look at the data on what percentage of all of our fresh IVF cycles that we have embryos available for freezing, it's just over 70% of the time. So it's quite a high percentage of the time that they have stuff available for freezing. Question, can I have 2 transfers if I really want to have twins and just be done? Well, I wish I could answer that question for you. There's so many factors that would really be involved in making that decision. Our goal is never to try to purposely give somebody twins, right? We just don't feel like, even though you know, you could probably handle it and it'd be fine, sometimes there's risk for the baby, and you just, you know, if we can try to minimize that, we're going to try to minimize that. But that's definitely something between you and your physician to discuss and kind of weigh the pros and the cons of transferring more than 1 embryo if you're at a high risk for twins. I'm 35 and I've had 2 transfers with my first pregnancy, and now my doctor says I can only have 1 transfer now. Is that correct? So and I don't know, you know, everybody's situation, right? So some of this all depends on what your embryo quality is. And it says after my first pregnancy, I really don't know. So we reset it. If somebody has had a pregnancy, a successful pregnancy, then kind of the criteria resets, right? So it's not 2 transfers in total, and then the 3rd transfer automatically you would get 2 embryos transferred. Because if you've had, you know, success, you know, you're at a high risk for multiples. You're at a high risk, high chance of conceiving with 1 embryo. So you just want it to be as safe as possible. Okay. So do I have any other questions today? I think these are really fantastic. And I wish I could be very much more specific about individual cases, but there, as you know, if you've gone through IVF, there's so much that's involved in all the decisions that you're making between you and your physicians, and everyone has different risk factors, and that has to be really weighed because, you know, you don't want to put yourself in harm's way, and you certainly don't want to put your babies in harm's way. How many embryos on average are there to freeze if one is 37 or 38 years old? Okay, that's a really good question, and it all depends on the starting number, right? So if I were to break it down, so about 80% of all the eggs that we retrieve are mature, right? And even capable of being fertilized. So let's say you had 20 eggs, just throwing out a number, and we're going to assume 80% of those eggs are mature. So that means 16 of those eggs would be mature. And then we're going to say, you know, maybe 80% of those will fertilize normally. And then we've already dropped that number down to, you know, 9 or 10 that fertilize. And then out of that, we say about 50% become blastocysts, 50 or 60% of those become blastocysts. So let's say on the high end, 5 or 6 become blastocysts. And then about half of those are high quality and meet freezing criteria. So there you're already at, you know, 3 or 4 embryos that we make freezing criteria. So after transfer, it's really hard to say how many embryos you would have available, but a lot of it all depends on your starting number of eggs and how many that fertilize. if I only have poor quality embryos, can I just keep them frozen even if the chance is low? So I have to say that we are very, the way we go about deciding what we're going to freeze, we're very liberal in what we're willing to freeze, much more so than a lot of programs actually, just because we have a lot of competence in our embryos and our freezing protocol. So really, you know, if these embryos have like really a chance of initiating a pregnancy or a healthy pregnancy, we do freeze those embryos. So the other ones that we are not freezing, really, they've timed out. They've really pretty much arrested in development, and you know, it just isn't right to freeze these embryos and give a patient false hope that these may initiate a pregnancy down the line. Because if anyone's been through this, they know all of the shots that are involved for several weeks, daily injections for something that really probably has very little chance of initiating a pregnancy, and we really don't want to do that to patients. So we want to, you know, be honest and forthright on the chances and the quality of these embryos. Having multiple abnormal embryos and only 2 normal within the same cycle having multiple abnormal embryos and only 2 normal within the same cycle gives impact the quality of those 2 normals. What are the chances of an abnormal baby? Oh no, not at all. Not at all. So each of these, consider them completely individual, independent events. And to have, so what you're saying is there were 5 embryos and then 40% of those really were normal. That's really good. So absolutely, the other ones have no bearing on that whatsoever. So when it's a euploid embryo, they do quite well. And I really wouldn't even, the abnormalities on the other ones is pretty normal, to be quite honest. So no, that wouldn't have any bearing on the other ones. Anybody else have any other questions I can answer? Well, I am thrilled to spend my Friday evening with you all. I really appreciate all the questions. I think they were quite excellent. I hope that you guys can gather, but we're really doing our best to create the perfect environment to culture these embryos. And our goal really is that you have a safe, healthy pregnancy, and that we're not putting anybody at any unnecessary risks. We do have a fantastic freezing program here at MGH, where if we were looking at our rates, that over 99% or 98% of the embryos that we freeze thaw just beautifully. And so we have so much confidence in our freezing protocol that we feel safe in transferring one at a time if patients have extra embryos available for freezing. So thank you. All right, well, thank you again for everybody for participating this evening. I hope you've learned a lot about embryo grading. It's some topic near and dear to my heart. And, you know, these webinars are going to be saved and put on our website. So feel free, if you want to do any studying and looking at these images again, go ahead, and we're always available to answer any questions. So please feel free to reach out. All right, thank you so much and have a great evening.